Hello and welcome back. Welcome to the mcode. Today let's solve factorial of a given number. So here we are using recursive way to find a factorial of a number. Okay, now let's understand. Here I have written a code snippet. Let's understand it line by line. So this is the code snippet that will find the factorial of a given number. So here we have declared a fact function that will take a parameter of n, and we have a halt condition. If n less than equal to 1, we called it base condition, halt condition, or stopping condition. So in that case we are returning n. So if n less than equal to 1, we are returning n. Otherwise, if that condition doesn't exist, so we are calling a recursive function with n into factorial of n minus 1. So this is a recursive function, and we are passing argument as a 5. So now let's understand how this function is going to be run, like how recursion is going to work underneath the hood. So let's understand it. Let me draw. So we are calling a fact function with the argument of 5. So we have called a fact function. Now I'm checking, does 5 less than equal to 1? No. So we are going to make another recursion call with n into factorial of n minus 1. So let me write it. So it's going to be 5 into factorial of 4. So I have to draw it. We are going to make another recursion call with fact. Basically we have n is 5 into fact of 4. So now with the fact of 4 we are going to make another recursion call. So does 4 less than equal to 1? So let me write it. Does 4 less than equal to 1? No, it's not. So we are going to call another recursive function, which is 4 into factorial of 4 minus 1, which is going to be 3. So 4 into factorial of 3. So we are making another recursion call with the 3. So in that case, does we are going to check in the halt condition, does 3 less than equal to 1? No, 3 is not less than equal to 1. So we are going to make another recursion call which n into factorial of n minus 1, which is going to be 3 into, which let me write it, 3 into it is 3 into factorial of 3 minus 1, which is 2. So we are going to make another recursion call which factorial of 2. Does 2 less than equal to 1? No, 2 is not less than equal to 1. So in that case we are making another recursion call which is going to be like n into factorial of n minus 1. So here n is 2, so 1, so it is 2 into factorial of 1. So in that case, like, we are going to make another recursion call with the factorial of 1. But so in that case we met the condition, like we call a recursion call with a 1 and 1 less than equal to 1, which is true. So in that case our halt condition is going to be return n. So here we have n, which is 2. So in that case we are going to return 2. Okay, now multiply the computed value of fact of 2, which is returned from the fact of 1. So 3 into 2, which is going to be 6. So the fact of 2 is going to be return 6. So fact of 2 is going to return 6. So the computed value of fact of 3 is going to be 6. So we are going to multiply 4 into 6. So 6 into 4 we can write it, which is going to be 24. So the fact of 3 is going to be return 24. So here from that we have to return 24. So the computed value of fact of 3 is going to be returned to fact of 4. So here we are going to multiply 5 into 24, or 24 into 5, which is going to be 120. So from that we are going to return back at the factorial of 5, and at the end we are going to return the result, which is going to be 120. So the factorial of 5 is 120. Well, thanks for watching. Please follow, subscribe and like. Goodbye.